Hi everyone, welcome to
amazing channel of Brilliant Katha.
When you are rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Hi dear students, welcome to Brilliant Katha YouTube live session. Today I am going to discuss the MCQ questions from the chapter Continuity and Differentiability. You know, MCQ questions are very important in the CBSE board exams. 25% questions coming from MCQ and around 20 MCQs are there. First 20 questions will be MCQ. And the chapter Continuity and Differentiability is very important. Many MCQs questions will come from those chapters. Then we can go to the class. See, the main part is the continuity and differentiability. Here the function f of x equal to mod x is, that's a question. What's the question? First question. The function f of x equal to modulus of x or absolute value of x. Then which one is right answer? First option, continuous and differentiable everywhere. Continuous and differentiable nowhere. Continuous everywhere but differentiable everywhere except at x equal to 0. And continuous everywhere but differentiable nowhere. How can we check the continuity? How can we check the differentiability? That's an important point. How can we check the continuity? You learned that continuity is there. Continuity is there. You know, LHL equal to RHL equal to f of a. What is LHL? Limit extends to a minus f of x equal to limit extends to a plus f of x equal to f of a. That's the definition. Okay, so limit extends to a minus LHL equal to RHL equal to f of a. Then you know, how can we check it is differentiable or not? That means LHD equal to, you know, LHD, left hand derivative equal to right hand derivative. That's a normal method. These both cases at x equal to that constant at that value in the domain A. So the value of x equal to A. Instead of that one is an MCQ question. We want to do maximum within 2 minutes one question. How can we approach this question? It's a theoretical case. And what is actually continuity? Continuous means what? The graph of the continuity we can check. What's the graph of the continuity? When we draw a graph of the function, if you are drawing and should not lift your hand from the paper or should not lift pen from the paper. That means if you are drawing a line or graph, whatever the, check here modulus x graph is what? Modulus x graph is what? So you know modulus x graph is the V shape graph. What's the modulus graph here? You know, this V shape I'm drawing here and drawing here. See, I didn't take the, or I didn't lift my pen from the board. That means it's continuous everywhere. From where? This, you know, this negative infinity to positive infinity is coming, or x-axis is coming. Everywhere it is continuous, no breaking is there. So directly we can tell it is continuous. Okay. And it is differentiable or not. How can we check differentiable or not? Differentiable or not. Here, you know, f of x is equal to, you know the definition of modulus of x. Modulus of x means negative x, x less than or equal to 0, and x less than 0, and positive x, x greater than or equal to 0. This is the left side, this is the right side. I'm going to draw a number line here. A number line here. See, minus infinity to infinity. Where is the critical point is coming? Modulus of x, then x minus 0. Critical point is what? 0. So here 0 I am putting. 0. Its left is what? Its right is what? Left side of 0 goes to negative of x, negative x. Right side of 0 and equal to 0 goes to positive x. How can we check LHD, RHD? LHD equal derivative of left side, derivative of, or LHD at x equal to what? LHD at x equal to, LHD equal to derivative of negative x is equal to minus 1. So at the same time, RHD equal to RHD at x equal to 0. RHD means derivative of positive x. That is 1. What we can tell? LHD not equal to RHD. LHD left hand derivative not equal to right hand derivative. So LHD not equal to RHD means it is not differentiable at the particular point. Which point? At the particular point 0. And we can check the options. Okay. So here we can check the options. Continuous and continuous is the differentiable everywhere. No, not differentiable everywhere. Differentiable everywhere. That is wrong. And the second, continuous and differentiable nowhere. That is wrong. Continuous everywhere, but differentiable everywhere except what? Except 0. Yes, we found out that one. Last option, continuous everywhere, but differentiable nowhere. No. Differentiable is there, differentiable, but at the point 0 it is not differentiable. So which is the correct option? C. Option C is the right option. So I told you this is a normal method, but instead of normal method, what we are going to do, you just check from here once again. You just check from here. We just split the value modulus function left side of right side of that particular critical point. Minus x plus x. Here itself I can check what is LHL, what is RHL. LHL means negative x. LHL is equal to directly substituting 0 at the place of x0. RHL equal to directly substituting at the place of x is 0, and f of 0 equal to what? F of 0 directly 0 will come equal to 0. 1 point, finish. Second point, LHD derivative of minus x minus 1, RHD positive x derivative is plus 1, both not joining, LHD not equal to RHD. So it is continuous but not differentiable. Okay, then we can move to the next question. We can check what is the next. What is the question? See, the function f of x equal to modulus of x plus modulus of x minus 1. Options are there: continuous at x equal to 0 as well as x equal to 1. Continuous at x equal to 1 but not at x equal to 0. Discontinuous at x equal to 0 as well as x equal to 1, both discontinuous. And D, continuous at x equal to 0 but not at x equal to 1. Then what will be the answer? Previously I told, how can we find out that one? Mod x already we checked, the continuous everywhere. Mod x, modulus function. Some functions are continuous everywhere. Modulus function, polynomial function, sine function, cos function, these all continuous everywhere, and other trigonometric functions are continuous on its domain. Okay, anybody is giving the answers here? Any option? Okay, we'll see. First one we already told. We discussed that one. What is that? Modulus of this x, negative x and positive x, continuous. How can we check? LHL and RHL checking. LHL, RHL checking. So here LHL equal to what? At 0. LHL equal to 0. RHL equal to what? RHL equal to x. Substitute the value 0. And that same equal to f of 0. This is continuous already. We discussed. This continuous. Okay. This continuous. Second one, modulus of x minus 1. How can we check modulus of x minus 1 continuous or not? Check that. Modulus of x minus 1. There was a critical point there. X minus 1. Critical point is what? Plus 1. So 1. 1 is the point. After modulus of after 1, what will happen? Positive side of x minus 1. So it will come to x minus 1. This goes to x minus 1. This goes to negative of x minus 1. Negative of x minus 1. Positive of x minus 1. Same idea. We substitute the value at x equal to 1. What will get? At x equal to 1, LHL goes to what? Minus of 1 minus 1 goes to, minus of 1 minus 1 goes to 0. RHL equal to what? RHL equal to 1 minus 1 goes to 0. LHL equal to RHL also equal to what? F of 1. Directly substitute f of 1 here. We'll get 0. All the modulus functions are continuous, I told. Then here both the part, that means x minus x is continuous, x minus 1, modulus of x is continuous, modulus of x minus 1 also continuous. Then we can check both will continuous or not. Yes, some rules are there. Okay, some rules are there. Here, what is the rule? F is continuous. F is continuous. F and g both are continuous functions. Then what are the rules? Algebra of the continuity. F plus g continuous, f minus g continuous, f into g continuous, f by g also continuous, provided by g of x or g not equal to 0. F by g where g not equal to 0. Here f plus g, f minus g, f g. So because we are checking f continuous, yes, g continuous, yes, then f plus g is continuous, yes. Similar question if you are getting, directly you can write there all the modulus functions are continuous. Then both are modulus functions. Both are continuous. Its sum also continuous. Product also continuous. And we can check the answer. Continuous at x equal to 0 as well as x equal to 1. Continuous at x equal to 0 as well as x equal to 1. Anybody is giving the answer here? Yes. Maybe given the answer here, option A is the correct answer. So, continuous at x equal to 0, it is continuous, and it is as well as x equal to 1. Continuous at x equal to 1, as but not x equal to 0, not correct. Discontinuous at x equal to 0, not correct. Continuous at x equal to 0, but not at x equal to 1, that is wrong. So, at the same time, what's the differentiability of this one? Question will come like that also. What's the differentiability? Mod x is not differentiable at x equal to 0. Mod x minus 1 differentiable? No, not differentiable at x equal to 1. The particular point, it is not differentiable. Okay, then option is here. Option A is right answer. We can check the next question. The points or point at which the function f is given by f of x equal to x by modulus of x. If x less than 0 and x greater than or equal to 0, it is continuous, is or are. Which value satisfy or which value we can give here for x? X belongs to r, x belongs to 0, x belongs to r minus set to 0, or x equal to minus 1 and 1. Which one is the correct answer? Yes, if you did that one, please send us the comment box. Yes, Tushar. Okay. Then we can check. I told you we can check like that only as on the number line. How can we check this function? You know, here modulus is coming where? Down. X, modulus of x coming the left side, what will happen? Left side it will come to negative of x will come. X by where modulus, that only change. X by negative x. And it is given that the right side what is happening. Left side is that one, right side is what? X greater than or equal to 0. From 0 onwards the value directly given minus 1. Then I am checking here, x by x goes to 1, this goes to minus 1, this value goes to minus 1 everywhere. You are starting from here minus infinity to plus infinity, minus infinity to plus infinity. The y value here you are getting x by x cancel and minus is there minus 1, minus 1. So LHL equal to what? Minus 1. RHL equal to what? RHL equal to, yes, right side, minus 1. And f of 0 equal to what? Minus 1. Everywhere minus 1. From where to where? Minus infinity to infinity. If you see the previous questions, mod x, we checked. Mod x minus 1 we checked. Now we are checking this point which function is given by continuous in where? All the, yes, shiny sabu. Answer is A, correct answer. So here, answer A, what is the answer A? X belongs to R. R means what? Minus infinity to plus infinity. Minus infinity to plus infinity is coming here. X belongs to R is the right answer. So if you do more questions, it will be C because you got the idea what is the continuity and differentiability. Next questions we can check. The function f of x equal to e raised to modulus of x is, again asking continuity or differentiability. Here continuous everywhere but not differentiable at x equal to 0. Continuous and differentiable everywhere, not continuous at x equal to 0, none of this. Which will be the right option there? Okay, which will be the right option there? Maybe. Yes, Shiny. Correct answer. Maybe please say continuous everywhere but differentiable or not. Modulus function differentiable or not at x equal to 0. Yes, Shiny Sabu. Correct answer A. Good. Yes. Tygun or Tygun. Okay. Yes. Yeah. Yes, maybe. Okay. It's A only. Understood now. Okay. So I'm not checking the other values or nothing is there. Directly I don't know. You just draw a number line again. Number line. Modulus is that case. Modulus case is there. Just draw the number line. Check what is the left side, what is the right side. So here where x is there, x minus 0, 0 is a critical point, so splitting the limit is 0. After that x, after the right side what will get? So means e raised to x is no, e raised to what will get? Positive x. Right side, negative what will get? Negative side. This goes to what? Negative side. E raised to negative x. Checking LHL equal to what? LHL equal to what? LHL equal to, we can apply the limit as 0. I am not writing limit this x tends to 0 minus e raised to negative x. Not writing as a MCQ question, maximum fast you can do. That's fine. Okay, so I am not writing that steps, short, maximum short only. So here LHL equal to, substitute there, e raised to minus 0 goes to minus or plus, no problem, 1 by e will come, e raised to minus x goes to e raised to minus x goes to 1 by e raised to plus x, 1 by e raised to 0, 1 by 1 will come. Then now this goes to directly 1 and RHL equal to what? RHL equal to e raised to 0. Substituting equal to what? 1. Yes, f of 0 equal to what? F of 0, this what? X greater than or equal to 0. E raised to 0 goes to 1 again. LHL equal to RHL equal to f of 0. So definition of continuity. It is continuous. Continuous. Where? Everywhere. So, continuous means this left part continuous, sure, right part continuous, sure. We are checking at the particular point 0, it is continuous or not. Yes, it is also continuous, means everywhere it is continuous. Next, you want to check the differentiability, right? So, same idea I told first onwards. LHD, check that. LHD at x equal to 0. What's the derivative of that one? LHD at x equal to 0, we can check. LHD means e raised to negative x derivative. E raised to x derivative? E raised to x itself. E raised to negative x derivative? Negative of e raised to negative x at x equal to 0. At x equal to 0 means what? No. At x equal to 0 means this goes to minus e raised to minus 0 or 0, whatever the minus 1. RHD equal to what? RHD at x equal to 0. E raised to x derivative. E raised to x itself. E raised to x. And apply the value x equal to 0. E raised to 1. C equal to 1. LHD equal to? No. RHD. LHD not equal to RHD. LHD not equal to RHD. Then what's the condition? It is not differentiable at the particular point 0. Then we can check the options here. Continuous everywhere but not differentiable at x equal to 0. First read, we got the answer, Continuous and differentiable everywhere. No. Not continuous at x equal to 0. No. Then which is the correct option? A. Continuous everywhere but not differentiable at x equal to 0. Yes, answer is A. Yes, Tushar. Taigun. Mevin. Yes, good job. All are getting the right answers only. Okay, we can move to the next question. The function f of x equal to x into modulus of x. Why keeping many questions in the modulus? Because that much important modulus and the greatest integer function, signum functions, this all. So here, x into modulus of x. The function f of x equal to x into modulus of x. X belongs to R is differentiable when? Only at x equal to 0, only at x equal to 1, C only, in all the real numbers, and D in R minus set 0. R minus set 0 means except 0 the value. Yes, we can check that one. X into modulus of x. Chance of mistake is more. Okay, x into modulus of x is there. Answer coming A, D. D is getting the answer. Thank you. So here, sure, definitely we can meet. So, what is the next step? Students are getting the mistake here because you are checking, sir, mod x is the differentiable, will not come. Don't learn like that. Please check the rule. Directly, x is differentiable or continuous. Mod x is the continuous but not differentiable. You know the definition of all the differentiable functions are continuous also, but all the continuous functions need not be differentiable, not vice versa, both are not true. So here we can check x. I told you, x is there. I'm just writing or drawing a number line again. Here I am taking x, mod x is coming the critical point as 0. What's the left side will come? Left side will come to x into negative x or negative x square will come. Left part. Right part. X into modulus of x goes to positive part, x of x square. X times of x square. Minus x square plus x square. But at x equal to what? 0. LHD we can check LHD. LHD equal to derivative of minus x square. That goes to minus 2x. LHD at x equal to 0. LHD goes to negative 2x at x equal to 0 means what? Minus 2 into 0 goes to 0. Got it? RHD equal to what? RHD at x equal to 0. RHD derivative of x square goes to 2x. At x equal to 0. 2 into 0 goes to what? 0. Yes, LHD equal to RHD. LHD equal to RHD now means what? LHD equal to RHD means it is differentiable everywhere, because you know this function goes to actually f of x is equal to negative of x square x less than 0, positive of x square x greater than or equal to 0. Okay, x square is always differentiable, continuous, because x square, that part, it will be differentiable and continuous. Negative x square, x less than 0, negative x square, this is also continuous and differentiable. Where we want to check at x equal to 0, it is continuous or differentiable, we want to check. Yes, it is continuous, it is differentiable. See, only at x equal to 0, no. Only at x equal to 1, no. In all the real numbers, yes, in all the real numbers, it is what? Differentiable. Hope you understood. Many students got the wrong answer. Please see. Because don't check only modulus of x at x and the modulus of x at x equal to 0. That is we want to check there. Okay. Yes, my older students joined in the class, I think so. Okay, thank you all of you. Where I am teaching now. Yes, this is the banner, the Brilliant Institution, Qatar. Yes, thank you. Yes, we can move to the next question. Hope all of you understood. What is that? Next question. Yes, the function, just change it there. The function f of x equal to greatest integer x, where x denote or box x denote the greatest integer. Function is continuous at where it is continuous, where it is discontinuous. You should know that one. Okay, what's the greatest integer function? Graph of the greatest integer function. Graph of the greatest integer function is very, very important for calculating or for knowing that idea. See, what's the greatest integer graph will come here. That just graph all, I am not drawing the correct points and all. You know this one. So it will come to here. It will come to from 1 to 2, you know, 1 to 2. And 1 closed here, 2 to 3, like that. This closed and this will not reach here. You learn that one, just showing the idea. Where? See, what is the continuous function? Continuous means what? Continuous means we want to draw a line without lifting the pen from the paper or board. So here, everywhere it is discontinuous actually. Okay, reason is there, in the greatest integer function you learn that 1.3 goes to 1 only. 1.4 goes to 1 only. 1.9 also goes to 1 only. Okay, so it is closed or greatest integer x equal to a means what? Means a less than or equal to x less than a plus 1. A less than or equal to x less than a plus 1. It will come to the greatest integer here. So here it will come. Then you know, it is always discontinuous at where? At that integral part or integer part. Integer part it is discontinuous. Okay. So greatest integer function discontinuous where? It's a integer part. Example, if we are taking 1, 2, 3 like that. You know, if 1 to 2 goes to what? 1 to 2, you know, 1.9 I wrote there, that goes to 1 only. That means greatest integer function discontinuous at every integral points are there. Then the function f of x is continuous at 4. No, 4 is an integer. 4 is an integer. Minus 2 is an integer. 1 is an integer. 1.5 is getting the answer. Odd one. 1.5 is there. Okay. 1.5 here, the answer is there 1.5. That means from here to here, it is continuous. Don't think greatest integer function is always discontinuous. It is continuous in its particular domain. That means it is continuous if you are taking 1.5 or you are taking if x equal to 1. 1 less than or equal to x less than what? 2. 1 to 2 infinite points are there because real numbers. 1 to 2 it is continuous, that I mentioned here. 1 to 2 here continuous then. Okay, then this is continuous in that particular part. That means 1 to 2 it is continuous. But from 2 it is discontinuous. So greatest integer function always discontinuous at every integer points or integral values of that one. Clear? So answer is what? Answer is option D. Yes, Mavin, Shiny. Yes. Okay. Okay, thank you all of you. Yes, go to the next question. F of x equal to x square into sine 1 by x, where x not equal to 0, the value of the function at x equal to 0, so that the function is continuous at x equal to 0. The value of the function x equal to 0, we want to find out the value of the function. Conditions are there. Okay, so how can we check that one? X square, limit x tends to 0, we can check, of x square into sine 1 by x equal to what? You want to check at x equal to 0, what is the value of limit x tends to 0, x square into sine 1 by x. Yes, answers are coming here. Yes, what is the answer maybe? Shiny? Yes, good. Yes, congratulations, Shiny. That's correct answer. Within seconds, gave the answer here. Okay, you can check that one. So here, x square into sine 1 by x is equal to what? Substituting the value, right? So x square means 0 square, 0 into sine of 1 by 0. That means 0 into sine of, we are writing here not defined or infinity. Okay, what is the sine value of like that? Sine infinity or sine not defined? What we will write there? The value of sine, range of the sine value is what? Range of the sine value is what? -1 less than or equal to sine theta less than or equal to what? That means it will -1 from +1. -1 to 1. The value of the least value of sine is what? -1. The greatest maximum value 1. So we can write this value is -1 between or from -1 to what? From -1 to 1. So 0 into what? 0 into that value between -1 and 1. 0 into any number goes to what? 0. Then what's the answer? Answer is here. What's the answer? Answer is 0. Very easy. Hope all of you understood. Yes, got the correct answers here. Thank you all of you. Yes, move to the next question. The value of k. Now only I explain. The value of k, for which makes the function defined by f of x equal to sine 1 by x, x not equal to 0. And k if x equal to 0. Find the value of, k. What is the value of k? What will get there? That's waiting for your comment. Yes, answer got here. A, B, C, D. What is the answer? Yes, Aisha. What is the answer? We can check. Sine 1 by x. I am taking here the value. Limit x tends to 0, sine 1 by x, right? Sine 1 by x. What will get there? Same only we discussed the previous one. Yes, correct answer came here. Okay. So here, sine 1 by x is the sine 1 by x means limit x tends to 0. Sine of 1 by 0, sine not defined or infinity will come. What I told. This goes to the value between -1 and 1. Any particular values there? No. 8, no chance. -1, how can we check a particular number is there? And 1, we cannot tell that particular. If you are taking -1, 1 also right answer, no? So, from -1 to 1, any value we don't know. So, what is the correct option we can take from here? From the options only. Okay. So, from the options we can write there, none of this is the right answer. None of this. Hope you understood the reason. The value of k we cannot define here because the range is always range of the sine function always from -1 to +1. Hope you understood. Answer D is the correct option. Next question. The function f of x equal to cot x is discontinuous on the set x equal to n pi, x equal to n pi, x equal to n plus 1 into pi by 2, x equal to n pi by 2, n belongs to set. How can we check, We want to check cot x equal to, right? F of x equal to what? F of x equal to cot x. F of x equal to cot x. What is cot x? Cot x we can write as rational function. What is the rational function? F of x by g of x from cos x divided by sin x. Cos x divided by sin x. What's the condition? Denominator means sin x not equal to 0. Word provided, denominator not equal to 0. We want to check these type of questions. The denominator is equal to 0. Condition is there. What is that? A function, rational function f of x by g of x provided g of x not equal to 0, or where f of x by g of x where g of x not equal to 0. So here sin x not equal to 0. Sin x when it will come to 0. Cos x is discontinuous when sin x goes to 0. Sin x goes to 0, it is discontinuous. When sin is going to 0, that also sin 0, 90 degree, minus 90 pi by 2, minus pi will come, 3 times of pi by 2, and 2 pi, 3 pi, 4 pi, etc. will come. The maximum value of sin is 1. Minimum value of sin is -1. What will come as the graph? What will come as the graph? Sin 0, 0, sin 90, 1. Sin 180 goes to 0 again. Sin 3 pi by 2 goes to -1. It will come to again 0 where sin 2 pi goes to 0. Similarly, the negative part, negative 1 will come. And minus pi goes to 0, 1 will come, and again it will come to minus 2 pi. So, sin 0, 0, sin 1 pi, 0, sin 2 pi, 0, sin 3 pi, 0, sin 4 pi, 0. Or generally we can take sin n pi equal to 0. And that is called the general solution. Maybe you didn't learn in the last year because some topic deleted in the 11th class. Here, which one? 0 pi, 1 pi, 2 pi, 3 pi. Similarly, minus pi, minus 2 pi. Then what will come? Here, plus or minus pi will come. Plus or minus 2 pi will come. Plus or minus 2 pi will come. And 0 will come. Means, we can take here, that is n pi. N pi, sin when is coming to 0, then it will come to x equal to what? X equal to n pi, where n belongs to z, sin x goes to directly 0. At that time, it will be discontinuous. Cot x is discontinuous where? When sin x equal to 0. When sin x goes to 0, option A, x equal to n pi, where n belongs to z. At that time, it is discontinuous. So, option A is the right answer. No need to check the other one. Similar question will come. Tan x. Tan x means sin x by cos x. When cos is going to 0. Cos x goes to 0. Options are here 2n plus 1 into pi by 2. Okay, like that we have to practice then similar type of questions. Okay, I'm moving to the next question. What's the next question? The number of points at which the function f of x equal to 1 by x minus greatest integer x is not continuous. When? The number of points. See, that's a rational function again, f of x by g of x, 1 by x minus greatest integer x. You know, x minus greatest integer x is there. If it equal to 0, if it is equal to 0, that function will be discontinuous. Okay. The number of points at which the function f of x equal to 1 by x minus greatest integer x is not continuous. When it is not continuous? Very simple idea. When? Every integral points. Because x equal to greatest integer x only happening when x and the x, that x will goes to greatest integer function, no? X goes to integer. That means if x equal to 2, then 2 and these both are 2. These both are equal. Or greatest integer 3 is equal to 3 only. So at the denominator, the same value coming only when it will happen. So in integer case only. Yes, option is correct. Maybe correct answer. So here 2 and 2.5 are taken. What's the 0.5 is equal to only will come. Example, x minus greatest integer x. Here I am taking x equal to 2.5. 2.5 minus 2.5 goes to what? 2.5 minus greatest integer 2.5 goes to 2.5 minus greatest integer 2.5 goes to 2. Then answer will come to what? 2 only will come here. The value, this 2.5 goes to what? This goes to 2. Then 0.5 will come. So let's define denominator. So here all the integral parts, it is discontinuous. All the integral parts. So z is, we can take here all the integral part. So not only one correct only, 2 correct only, 3 correct only. But what's the right answer from here? Here it will come to what? None of this. Hope all of you got the idea. Yes, answer is the correct answer. We can check the next question. F of x equal to 4 minus x square by 4x minus x cube. Students, please check that question properly, read properly. Chance of mistake is there. We learn simplification, directly we'll go to simplification. Please don't do like that. What is given in the question? According to the question only we want to write the answer. Okay. So what is the correct answer? How many students are giving the answers here? Yes, good job. Congrats. Yeah. So we can check. What's the question here? F of x equal to 4 minus x square 4x divided by 4x minus x cube. I told you rational function. Denominator 4x minus x cube equal to 0. At that time it will be discontinuous. Denominator 0 coming means not defined will come. It will be discontinuous. So here 4x minus x cube is there. 4x minus x cube. How can we write that one? X common. 4 minus x square equal to 0. Either x equal to 0 or 4 minus x square, 4 minus x square equal to 0. One point we got x equal to 0, other point x square equal to 4 or 4 equal to x square. X equal to what? Plus or minus 2, root of 4 plus or minus 2 will come. So how many points are there? 0, 2, minus 2. These all the points, it will be discontinuous. It will be discontinuous here. That means which option is correct? Discontinuous at exactly 3 points. Okay, no need to think that much. Denominator check. How many points if you are substituting x, it will come to 0. 0 means not defined. Clear? Let's move to the next question. The value of f of x kx plus 1 if x less than or equal to pi. Cos x if x more than pi at x equal to pi is continuous. You know how to check that one. K value. Very easy question. Direct question. Find the value of k. You know, no need to check the detailed steps. Directly check. Short way. LHL equal to RHL. What is LHL? X less than pi. LHL equal to what? K into at the place of x pi plus 1 equal to cos of RHL. LHL equal to, you can put the RHL. LHL equal to RHL. K pi plus 1 equal to cos pi. K pi plus 1 equal to cos pi is negative 1. And K pi equal to minus 1. Plus 1 take to other side. Minus 2. K equal to minus 2 by pi. Check the option is there. Yes, option B is the right answer. Very simple question, direct question. Minus 2 by pi. Clear? Okay. I hope that's enough. We'll understand. All are getting the correct answer. Good, good. And move to the next question. A function defined by f of x equal to k cos x by pi minus 2x. If x not equal to pi by 2. So LHL, RHL, same idea. But how can we check that one? We can use the one other method, shortcut method, L'Hospital's rule. What is L'Hospital's rule? L'Hospital's rule is what? If the function is coming f of x by g of x, f of x by g of x is coming as 0 by 0 form, indeterminate form, 0 by 0 form, we can do L'Hospital's rule. What's L'Hospital's rule? F dash x by g dash x. What is that? F dash x by g dash x at x equal to that particular value may be a. F dash x divided by, not quotient rule, not u by v all dash, not quotient rule, derivative of numerator by derivative of denominator. Once again getting 0 by 0, once again take L'Hospital's rule. At that time, f dash double dash of x by g double dash of x at the same point x equal to a will get. That means again, once again take as the derivative. Okay, so we can check that method. I'm not doing the normal method, descriptive method I'm not checking. That you know. How can we find out this answer? Please listen. K cos x by, I'm taking the limit. So k cos x means k into derivative of cos x minus sin x by, this is LHL actually, LHL equal to RHL, that only we are checking. So here k cos x by pi minus 2x, pi minus 2x, and f of x also, the f of pi by 2, f of pi by 2 also we can take. LHL equal to or RHL equal to whatever there. So limit equal to f of pi by 2. X k cos x pi minus 2 is taken derivative by L'Hospital's rule. See, k into sin x cos x derivative minus sin x, pi derivative, pi is constant 0, minus 2x derivative, x derivative is 1. So minus 2 only equal to f of pi by 2 means 3. Over. Minus of minus goes to, minus of minus goes to plus. Sin at the value we want to substitute here at x equal to what? At x equal to pi by 2. You know, k by 2 is there, k into sin pi by 2 goes to what? Sin pi by 2 goes to 1. 3 into 2 or 2 3s are 6. K into 1 equal to 6. K equal to what? 6 is the answer. K equal to 6 is the right answer. Hope all of you know this method, L'Hospital's rule. Okay, it's fine using the shortcut way. Yes, answer is maybe. Answer is C. Maybe Shiny. Yes, Hannah. All are giving the right answers only. Yes. Good job. Yes, move to the next question. What's the question? Same idea. L'Hospital's rules again, but a small difference is there. So I am checking again L'Hospital's rule. Again I am checking L'Hospital's rule. What's the method? Take the derivative of that one. Take the derivative, limit we are taking directly. Take the derivative of this one. Cos 3x, you know, cos 3, it's a derivative. F dash x by g dash x. Derivative. Cos 3x, cos derivative minus sin. 3x is the chain rule will come. Minus 3 sin 3x. Minus cos x derivative. Minus is there, cos x derivative minus sin x. Minus of minus plus sin x by x square derivative 2x. I'm checking here it will come the answer or not. See, is equal to the value f of 0 equal to lambda directly. Minus sin 3x, I am substituting x equal to 0. What will get? Please check. Here will come to 0. Sin 0 goes to 0. minus 3 into 0, 0, sine 0, again 0, but here 0 again will come to 0 by 0 form, indeterminate form. At that time, what we want to do, once again take the derivative by L'Hospital's rule. What's the derivative once again? Please see, minus 2 sine 3x, minus 3 sine 3x. So it goes to minus 3 3s are 9. Sine 3x goes to cos 3x. Sin x derivative goes to cos x by 2x derivative 2 equal to lambda. Now substitute the value of x equal to 0. Goes to minus cos of 0 plus cos of 0 by 2 equal to lambda. Minus 9 into cos 0 minus 9 into 1 only, minus 9 into 1 plus cos 0 1 by 2 equal to lambda. What we'll get? We'll get to minus 9 plus 1 minus 8 by 2 equal to lambda. Therefore lambda goes to what? Lambda goes to minus 4. We can check the option is there or not. Yes, minus 4 is the right answer. Minus 4 is the right answer. I'm telling, use the L'Hospital's rule. That type of questions. Okay. Hope all of you understood. I move to the next question. Yes, many students gave the answer here. Thank you. Thank you. Which one? Chain rule. Y equal to sine square of x cube. Direct question only. Very easy question. Find dy by dx. Y equal to sine square of x cube. So dy by dx equal to what? Sine square. Sine square we can write sine x cube whole square. Okay. X raised to n derivative. Nx raised to n minus 1. Sine derivative is cos x. X cube derivative equal to 3x square. For understanding only about that, you know what you want to do. So x raised to n form, that goes to n into x raised to n minus 1, 2 sine x cube. Sine derivative goes to cos of x cube. Derivative of x cube goes to 3x square into 3x square. Throughout multiplying 2 3s are 6, x square rearranging. Sine of x cube, cos of x cube. According to the options we can write same option is there, I think so. 6x square sine x cube and cos x cube is there in the options. Please see what's the question, what's the answer. Answer C is the right option. Yes, many students gave the C. Shiny, Ruben, Mevin, Hannah. Yes, thank you all of the students. Please see the next question. Please see the next question. Log sine e raised to x. Same idea, chain rule only. In one step, how can we do? In one step, no need to write that much steps. Dy by dx or y dash equal to dy by dx equal to log derivative 1 by which one? Sine 1 by sine e raised to x into sine derivative, chain rule is coming. Sine derivative cos of e raised to x into again e raised to x derivative, e raised to x itself. So, what is cos by sine? Cos by sine is cot. So, cot e raised to x. E raised to x we can keep first or last, no problem. Answer is there. Within the seconds you will get the answer. E raised to x into cot e raised to x. Yes, again option C only, right? Okay, move to the next question. Cos x minus sin x by cos x plus sin x y equal to, then dy by dx equal to what? Then dy by dx equal to what? See, this type of question, what we want to do? Option check the options. 6 square is coming, log sec x is coming, something we want to think about that. Which derivative is sec? Which derivative is sec? Or 6 square? Tan derivative, right? Any chance to make to tan this one? No need to go to quotient rule, Chinese. No need to go to quotient rule. You know, convert to tan. How can we convert? This completely divided by cos. Cos x, quotient rule if you are going means will take time. Instead of that one, we can convert to what? Throughout divided by what? Cos x. Then function y goes to cos by cos 1, sin by cos tan x, cos by cos 1, plus sin by cos tan. 1 minus tan x by 1 plus cot x result is there. You should learn. What is the result? Tan pi by 4 minus x. Is it? Because you know this result. Tan 1 means what? Tan 45 degree, tan pi by 4 minus tan x by 1 plus tan pi by 4 into tan x. That same will come. Tan a minus tan b by 1 plus tan a, tan b goes to tan a minus b. Directly we can take here tan pi by 4 minus x will get. So you can learn directly. Okay, no need to tan a minus tan b by 1 plus tan b. 1 minus tan a by 1 plus tan a equal to tan pi by 4 minus a will come here. X is that's why x. Take the derivative of this one. What's the derivative? Dy by dx equal to, tan derivative is what? Sec square. Sec square into pi by 4 minus x, but one chance of mistake. Negative x is there. Negative x derivative is what? Minus 1. So answer is what? Minus of sec square pi by 4 minus x is the answer. Sec square, negative of sec square pi by 4 minus x. Yes, it is there in the first option. Yes. The first option is the right answer. Minus sec square pi by 4 minus x. Hope all of you understood. Please learn this one. Which one? 1 minus tan x by 1 plus tan x equal to tan pi by 4 minus x. Similarly, 1 plus tan x by 1 minus tan x equal to tan pi by 4 plus x also. It will be helpful for shorting. So here, next question. See, type of questions are very important. Root of, if I explain this question, next question directly within seconds you will get the idea. So y equal to root of sin x plus y. I am taking squaring on both sides. Sin x plus y. Sin x plus y. Not sin of x plus y. Sin x separately, y separate. Sin x plus y. What to do? I am taking here y square minus y equal to what? Sin x. Take differentiate on both sides with respect to x. What's the derivative? Y square derivative? 2y. Not only 2y, 2y dy by dx required because we are taking derivative of y with respect to x minus derivative of y dy by dx. Derivative of sin x, cos x. Derivative of sin x goes to cos x. Then dy by dx is common. 2y minus 1 into dy by dx equal to cos x, equal to cos x. Therefore, dy by dx equal to what? Cos x divided by 2y minus 1. Very easy. Just rearranging, squaring on both sides. Just rearranging, take the derivative and the cos x divided by 2y minus 1. Option A. Yes, option A. Hope you understood. Go to the next question. I'm not doing, you just tell the answer. What is that? Previous question only. So this part again repeating, where root of sin x plus root of sin x plus root of sin x is repeating. So the question goes to y equal to root of sin x plus y. Refer the previous question. Refer the previous question. Hope you understood, because from here again going to infinite terms, y equal to root of sin x plus root of sin x plus root of sin x, etc. This goes to infinite terms again. Again we can call that part is y. So y equal to root of sin x plus y, we can keep the same question as the previous. Then what we'll get here? We'll get to same answer. What's the same answer? I'm not doing because already done in the previous one. Please refer the previous one. Answer is cos x divided by 2y minus 1. Yes, move to the next one. E raised to x plus, variety of questions are there. E raised to x plus y equal to, let y equal to e raised to x plus, e raised to x plus, e raised to x plus, etc. to infinity will come, etc. to infinity will come. So e raised to x plus, e raised to x plus, e raised to x plus, etc. infinity will come. I am not writing that much because that is in the question. That's why I am taking this part again coming to infinite terms, etc. 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 is coming. So e raised to x plus y I am keeping. What's the next step? Y equal to e raised to x plus y, because this part extending as infinitely. That y equal to that one. I'm taking log on both sides. That's easy. Log on both sides. Log y equal to x plus y into log e. You know the result there. Log A raised to B goes to B log A. B log A. That rule I applied here. Taking derivative on both sides. Log y derivative 1 by y. Sorry, 1 second. Before that, log y equal to what is log E? Log E equal to what? Log E is equal to 1. So log E to the base E goes to 1. Now we want to take log y equal to x plus y. Then what we want to find out? Dy by dx. Dy by dx. See, I am taking like that. Log y minus y equal to x. I am taking dx by dy. Dx by dy. That's also fine. 1 by with respect to y. Differentiate with respect to y. Then what's the derivative of y? Log y 1 by y minus 1. But dx by dy will come. Dx by dy. Take the LCM here. 1 minus y by y goes to dx by dy. What's the reciprocal? Take the reciprocal. Goes to dy by dx equal to what? Dy by dx equal to y by 1 minus y. Y by 1 minus y. Dx by dy. Just taking the reciprocal. Dy by dx equal to, yes, correct answer. C is the correct answer. Yes, very good, very good, very good. Move to the next question. What's the question? Find the derivative of, yes, very important, logarithmic function, power function, f of x raised to g of x. Y equal to x raised to 2x I am taking. Log y, take on both sides log y. 2x log x. Differentiate on both sides. Differentiate on both the sides. Differentiate both the sides. What will get? We'll get to 1 by y dy by dx. This is the product rule will come. What is the product rule? First into derivative of second plus second into derivative of first. First into derivative of second plus second into derivative of first. So we can take first into, or 2 we can take outside also, no problem. 2 is a constant. 2 into first into x into derivative of second 1 by x uv dash plus vu dash. Second into derivative of first. Second is what? Log x. Derivative of first 1. So dy by dx equal to what? Dy by dx equal to this y I am taking to right side. Y taking to right side 2y into x and x will be cancelled there. X and x cancel, then goes to 1. Log x into 1 goes to log x. But check the answer. 2y is not there, but y is what? Y we took as x raised to 2x, x raised to 2x. So y substituting 2 into x raised to 2x into 1 plus log of x. Answer is there, I think so. Which option is correct? Option is there? Yes, option is there. Which option is there? Option again came as C, 2x raised to 2x. Okay, answer is there on the option. So A, B, C, D. C is the correct option, and move to the next question. Very, very important question. Many question paper you can see this question. Inverse trigonometry. Y equal to sec of tan inverse of x. 2 methods are there. Any of the method you can follow. So one method only I am telling. Normally class what you did. Check that one. I am just drawing a triangle here. Just drawing a triangle. This is inverse trigonometry method, that's why. Tan x, you know, tan x equal to theta, tan inverse x, right? Tan inverse x equal to theta, then x equal to what? Tan theta, x equal to tan theta. X equal to tan theta means, which side by which side, you know, tan theta? Tan theta means opposite side by adjacent side. So x by 1 here. Tan theta means x by 1 goes to opposite side by adjacent side of the right angle triangle here. Theta equal to x by 1. Use the Pythagoras theorem there. Base square plus altitude square equal to hypotenuse square. But hypotenuse equal to what? Root of base square 1 square 1 plus altitude square x square we got. Then what is sec theta will come here? Please see, sec theta equal to what? Sec theta, which side by which side? Hypotenuse divided by adjacent side, goes to root of 1 plus x square upon 1 or root of 1 plus x square, sec theta. Therefore, theta equal to what? Sec inverse of root 1 plus x square. Now you write this much steps, directly make from here using this triangle, directly write here sec inverse what? Root of 1 plus x square. Sec and sec inverse we can remove. Then goes to 1 plus x square. 1 plus x square. Now, what's the derivative of that one? Dy by dx derivative of that one. Root function derivative 1 by 2 root x, chain rule, 1 by 2 root of 1 plus x square into derivative of inside the root. 1 plus x square derivative, 1 derivative 0, x square derivative 2x. So 2x, which will be cancelled there. It will be cancelled, 2 and 2 cancel. Answer is there, x by root of 1 plus x square. Check the option is there or not. Yes, option is there. Option A, x by root of 1 plus x square. Got it? This is the answer. X by root of x square plus, root x by root of 1 plus x square. X by root of 1 plus x square. See, simple question, u and v form, du by dv form. Sin inverse of 2x and sin inverse x. How can we do shortcut way? Sin inverse of 2x into 2x into root 1 minus x square. Very simple idea. In the inverse trigonometry, you learned that x equal to, you put sin theta. Theta equal to what? Theta equal to sin inverse of x. If you substitute, what will get there? Sin inverse of 2 sin theta into root of 1 minus sin square theta goes to u we can take u. Sin inverse 2 into sin theta. What is root of 1 minus sin square theta? 1 minus sin square theta equal to cos square theta. Root of 1 minus sin square theta goes to cos theta. Sin theta into cos theta. Result is there. 2 sin theta cos theta equal to sin 2 theta. Sin inverse of sin 2 theta goes to what? Sin inverse, sin removed. Then 2 theta. Theta goes to sin inverse x. 2 sin inverse x is there. With respect to derivative, I have not taken the derivative. And v is what? V is equal to sin inverse x. Take the derivative of 2 sin inverse x. Sin inverse derivative 1 by root of 1 minus x square. Sin inverse derivative 1 by root of 1 minus x square. It will be cancelled. Answer goes to what? Derivative of u with respect to derivative of v. Derivative of sin inverse, that one with respect to derivative sin inverse x means its result will come to derivative of sin inverse x derivative by 2 by v means sin inverse x derivative. I'm not taking the derivative. I'm just taking what? If you take the derivative also, it will be cancelled. Answer is equal to what? 2. Answer is 2. Clear? Understood? See, a different question. Yes, this one is a different question. What's the next question? F of x equal to modulus of x, then f dash x equal to where? What? F of x equal to mod x. Then f dash x is equal to what? A different question, right? So, check that. F of x equal to modulus of x. Mod x equal to what actually? Plus or minus x, right? Simply we can put mod x equal to plus or minus x. What is the root of x square? What is the root of x square? That also plus or minus x, right? Plus or minus, that goes to plus or minus x itself. Now we are going to combine that. I am taking f of x equal to absolute value of x. That's more clear. Absolute value of x. Here absolute means modulus value. Modulus x means plus or minus x. It is same as root of x square. Root of x square. Hope you understood. Modulus of x I am changing to x equal to plus or minus x, or plus or minus root of x square goes to plus or minus x. We are comparing both. Now take the derivative of this function. What's the derivative of root of x square? Chain rule. Derivative is what? Dy by dx or f dash x itself. Enough. F dash x equal to 1 by 2 root of x square into derivative of x square is what? 2x, which will be cancelled. 2 will be cancelled. 2 will be cancelled here. Then x by what? X by root of x square goes to what? Mod x. X by modulus of x. What is x by mod x? Signum function. X by mod x is the, x by mod x started with modulus function. X by mod x goes to left side goes to 0 is the critical point. Left side goes to what? X by negative x. Right side goes to x by positive x. What is x by negative x? X by negative x goes to what? That's equal to minus 1. X by x goes to plus 1. X by x goes to plus 1. Minus 1 and plus 1. So, which option is correct there? Very clearly given there. 1. No, not plus or minus 1. X greater than 0. X lesser than 0. Both conditions are different. You don't think C is answer no? Plus or minus 1? No. When x greater than 0, lesser than 0 condition is there x by modulus of x. So, x we're providing x denominator not equal to 0, x not equal to 0. Then which condition only? The last one, x greater than 0, positive 1, x less than 0, negative 1. That is the answer. Clear? Understood all of you? So that type of questions you can practice very easily. You'll get the MCQs maximum short, make that one. And today I'm going to wind up the class. So again we'll join with the another session, another topic. Okay, bye bye all of you. Signing off today. Thank you.